Right, good day. My name is Jake Saunders. I'm VP and Managing Director at ABI Research. I'm based here in Singapore, and I've been here now, I guess, about 17 years. I'm primarily responsible for running the custom team as well as our syndicated research dedicated to the region. Today, I'm going to be giving a presentation that pulls out a lot of those insights from the current research we've got going across a number of different programs. So I'm going to be looking at 5G use cases which are driving industrialization. So what's my agenda? So initially, I'll just give a bit of a deep dive into a few key countries and what's driving their evolution from 4G to 5G. I'll then delve into what is 5G to be. How is 5G supporting the aims and goals of the enterprise or the commercial application business? Lastly, I'll then go into some of those use cases, which are very innovative, and then wrap up with some recommendations. So across the region, 4G is very well established, and 5G is very much on the ramp up. There are more aggressively rolled out countries in terms of like Japan, South Korea, and China, where 4G coverage is pretty much almost at 100% of the country in terms of population. And then in terms of 5G coverage of that population, it's certainly over 90% in the case of China, if not 95 or 94% in terms of Korea and Japan. In terms of the ASEAN countries, such as Singapore, Thailand, and Malaysia, 4G coverage very well established. It's very good frequencies. The 2.x frequency bands are very handy for 4G. And 5G, which is often using the 3.5 gigahertz band, does mean you have more cell sites required, and therefore that's a bit more challenging. But we are seeing strong ramp-ups in the case of Singapore. Yes, it's a little red dot, a small country, 95% coverage. In terms of Thailand, 90, and Malaysia doing a big catch-up, probably actually well over 70%, given that these numbers were collected in sort of fourth quarter 2023. So a lot of rollout for consumers, for business users on the go, but 5G can support a much more interesting applications. And fundamentally, that's what 5G is really about. So what we've been doing is doing a series of projects looking at smart manufacturing, smart warehousing, smart logistics, smart cities. But in terms of this focus, it's mostly focused on those areas. Where we're seeing the biggest hotspots, yes, is China. China has taken a very proactive attitude to the rollout of 5G to be, but other countries are catching up quite quickly. In the case of Japan and Australia and South Korea. And this research is a snapshot. In fact, there's a little bonus for you. If you're paying attention and you continue to right to the end of this presentation, I'll have a link to you to a report, which I've highlighted just at the bottom here. So there is a report, the review of the 5G ecosystem, adoption, and industrial use cases in Asia. This was a project which we did on behalf of the UK government, looking at Asia Pac. So we did this for the Department of Science, Innovation and Technology, DSIT, and this report is free for everyone to download. So how is that 5G ramp up going for enterprise? And how is it being used to actually simulate this wider adoption across the whole of society? Now, the expression is, build and they come is certainly true. And that was the case with 4G, certainly the case also with 3G, going back to the 2G, that build the base stations, you get the coverage, consumers desire and use the services, but it's such a transformative piece of technology in terms of cellular technology that we're seeing countries want to turbocharge their adoption and really integrate and embed 5G and in the future 6G into their economies, into their society, into the safety net for their people, and really grow the economy. So, for example, with China, they have their set sail 5G action plan, which is to build over 3,000 5G private networks by end of 2023. In fact, China's already blown that out of the water. They've already gone well beyond 3,000 private cellular networks. I think there are over 5,000 private cellular networks. So private cellular networks is where an enterprise puts in place its own base station infrastructure to cover its own campus, and I'll go into more detail about in the rest of the presentation. They're also having subsidies and stimulus plans, 5G subsidy for 5G standalone base station rollouts, as well as subsidies. Korea, similar strategy. There are tax benefits of 2 to 3% put in place, a cohesive strategy, a sort of 5G plus strategy to integrate coordination between the government, local government, and enterprise, increase R&D support for development of R&D content. So this isn't just about connectivity. It can also be things such as XR, so virtual reality, augmented reality. There's a lot of interest in that space right now. Japan has put in place a sort of $225 million R&D program to stimulate innovations. It's also put in place a master plan 3.0 for the regional deployment of ICT infrastructure to essentially make sure there's almost 300,000 5G base stations put in place by the end of March 2024. Singapore, small dot, yes, there's a lot of coverage, but again, it's also about integration of services. So the Singapore regulator for spectrum and technologies has a 5G grant set aside, almost 50 million to support up to 70% of project costs for 5G enterprise deployments. They've set up test beds, so the 5G open test beds help to set up, evaluate, and develop partnerships between government and university and commercial and business enterprise, and also setting educational programs to build up a knowledgeable and capable 5,000 5G professionals by the end of 2025. So this slide really goes to the heart of the matter. Factories do incredible things. They pump out a lot of goods. In terms of everyone's got a smartphone. There's 8 billion people on the planet. Pretty much everyone has a smartphone. So there's a lot of goods being produced in terms of cars, go through factories. They come out as they go in as components, raw materials, and they come out as a finished set of goods. Perhaps it's a smartphone, perhaps it's a car. But you delve into different facets of the process, there are inefficiencies. There's productivity needs to improve productivity. There's needs for better real-time information. There's need to improve safety. Safety has improved enormously compared to the 1900s, going back 100 years, where there's an awful lot of accidents and fatalities in factories. But still, there is a concern and need to focus on health and safety in the factory place. So on the left-hand side, you can see there's an inflow of goods and components. And then on the right-hand side, you see the outflow of those particular goods in terms of cars in this case. You can have suboptimal picking of goods in terms of making sure that space utilization is optimized effectively. That can be constrained. Much of the labeling of those components has to be done manually as it goes from the warehouse into the workshop. In terms of that real-time information on stock and flow, that can be very jagged and disjointed in terms of getting the information to the right people through different stages of the assembly process. Again, similar issue in terms of the assembly line, and then into quality inspection, where in terms of detection, accuracy drops over time for personnel, and the need for specialized labor is required, and that can be challenging in the current world and environment. And then in terms of what's stored in the warehouse, even as finished goods, so again, you can have sort of suboptimal picking of goods and suboptimal space utilization. So all this could be enhanced and improve that efficiencies. I love this slide. It really comes down to what we call the 5 C's. So the 5 C's of ICT digital transformation are collect, connect, check, control, and change. So different stages, different things are going on. So at collect, yes, you may have smart devices where people inputting information, tablets inputting information, perhaps even laptops. And then there are sensors. You have sensors which may be embedded into the fabric of the building or into the assembly line, which are then collecting information. So you have sensors collecting information. That then obviously needs to be communicated to do something useful with it. And in our presentation, I'm talking about cellular, go from 4G to 5G. There are other solutions. You can use Ethernet. That's entirely possible. You can use Bluetooth. You can even use Wi-Fi or Sigfox and other short-range technologies. But cellular is very versatile and goes for many different domains. And that can integrate into edge computing, into the cloud. And then we start to get into the turbocharged part of the equation here. We can get into check. You can do analytics, data analytics. checking of inventory and so forth. And then you can move into control. In terms of control, you then got opportunities to apply AI, machine learning, in terms of the artificial intelligence, being able to take place and make sure goods are being optimized, also helping out with augmented reality and virtual reality, and even physical space manipulation with robots. So fundamentally, 5G is a force multiplier. When you use that broadband, you use that reliability, and also massive IoT integration into the environment, you can get that force multiplier. So how do we get that force multiplier placed into the enterprise? We've got opportunities to do so either with a private cellular network or with network slicing on the right-hand side. Left-hand side, don't want to go too much in the technical details, but fundamentally, you have a base station or a gateway, which is providing the coverage to different parts of the factory or the warehouse. You may also have an edge server, which is doing telemetry and monitoring and analysis, policy control, making sure you're keeping the bad guys out. And that's why I've got a dotted line. For some companies, they'll want to make sure it's a fully locked down network. Yes, they've got a cellular network, which is 5G, but it is private. It is not connected to the internet. It is not connected to the outside world. They've got full network control. They can optimize the coverage, and they also can integrate APIs. Again, another opportunity to turbocharge APIs to provide more monitoring. On the right-hand side, this is called network slicing. This is actually provided using the coverage of the operator's base stations and small cells, and perhaps even equipment into the cell site of the actual factory. And you may have other parts of the network, like an edge computer, also integrating into the core network, and actually perhaps pushing information out onto the cloud, onto the internet. And that may therefore offer benefits in terms of a lower cost of investment. It may be more suitable, for example, for tier 2 and tier 3 type companies who just don't have the infrastructure and the full-on IT support on the ground, in their own campus, in their own factory, to do all that maintenance, control, monitoring, and installation. Investment scenarios, they are ramping up. They are changing very rapidly. In terms of private cellular, we anticipate investment should reach almost 7.5 billion by 2027. And that's going into a number of areas in terms of hotspots, in terms of smart manufacturing, smart logistics, in terms of providing the background infrastructure for stadiums and event locations. What's interesting about stadiums locations, an opportunity also for network slicing, but I'll talk that in the next part of this particular slide. And then on the right-hand side, you got the network slicing investment from the telcos, and we're seeing now a big ramp up. And again, there could be many of the same areas because they are targeting some of the same verticals. But as I say, some of the tier 2 and tier 3 type companies may not have the capability to do a full-blown private cellular 5G network. And in terms of what we're actually seeing at some of these sort of Formula One, so here in Singapore, Formula One end user customers of Singtel were able to get different points of view snapshots from different parts of the racetrack using network slicing. And this could also be done in a stadium where you can get different points of view of the band playing on a stage. So we talked about investment, we talked about the technology which goes into it. Let's talk now about some of the use cases. I think I've got about 6 or 8 of them. So some key ones, certainly be asset tracking in terms of that optimal tracking of the components, making sure that you're using real-time location tracking. That could be RFID tags or could be RedCap. RedCap is a new technology that's coming out for 5G, which also helps support tracking and make them more effective. There are even more interesting technologies, passive IoT tracking components, which will really bring down the cost, but also improve tracking around the factory. So that'll improve safety, help to improve operational efficiency considerations, and that'll help to embed into inventory management, helping to track that flow of components and being able to update the databases in real time as it goes from raw components or individual pieces to then the full-blown product at the out ends and install in storage in the warehouse just outside the factory. In terms of enabling factory workers, managers, and so forth, The implementation of smart glasses will become quite crucial. So that helps with on-site and on-demand and helps improve efficiency. And we've seen these benefits, and for example, in LG's Smart Park, as well as Zulig's Pharma Smart 5G warehouse in Singapore. Another one is digital twins. So what is it? It's essentially a physical representation in a digital replica of perhaps an engine. In this case, I'm showing a sort of jet engine, but it couldn't be an entire sort of factory floor where you've got the lighting systems, you've got the assembly line, you've even embedded into that digital world, into the digital representation, the sort of friction and how those components wear out after a certain number of rotations or number of goods that have gone down the assembly line, so you can do preemptive maintenance and therefore be able to analyze that in real time. So, and all of these use cases complement each other. In the case of what we're seeing, for example, with Boeing, it's seen a 40% improvement in the first time quality of parts being used by having that replicated in a digital twin. In the case of predictive maintenance, an Israeli food and beverage company was able to reduce energy consumption by 25% by more optimized predictive maintenance and not having equipment on and wasted when it wasn't in operational performance, and therefore saved about 170,000. Another one would be, human-robot collaboration. This would be, for example, cobots. These could also be sort of personal robotic butlers, which are tethered to the use of our Bluetooth connection. So the worker can take goods off a rack or a shelf and put it onto the robot on the AGV and have that sort of transport the goods around the factory floor. And that helps to therefore support the functions and therefore optimize workforce, work personnel, and reduce issues with health and safety and such like. But what I really want to try and do is boil down, really crystallize for you what are those ROIs, what are those return on investments. And that fundamentally comes down to either improved production volume, which therefore translates to increased revenue production for the actual what's coming out of the factory, or it can help to improve profitability in terms of per goods having greater profits. So where could those, what we can boil down that, or those two components are those operational cost savings. So operational cost savings could come down, for example, reduced CapEx, where the equipment on the factory floor is more simple, more optimized in terms of the AGVs or AMRs. Don't need to have so much computational capability in the actual unit itself, and that is offloaded to the cloud. So you could have equipment which is cheaper to run as well. So that's reduced OpEx, so CapEx and OpEx savings, operational cost savings. And then secondarily, you've got production related OCS. So production, this ultimately is about what's coming off the assembly line. So if the yield of what's being produced increases from 70% to 80% to 90% quality, reliable, and doesn't have to be discarded, then you've improved your product yield. So again, this could improve your reliability of what's coming down the assembly line. Indeed, also personnel. If personnel are in the right place and they're safe and healthy, and you don't have to shut down the assembly line because of injury or an accident, or that you can monitor the performance and find out which ones are perhaps not understanding the task they have at hand and could be trained up further. That's going to improve personnel productivity. The last one is downtime. And ultimately, this doesn't reflect on what's being produced because you can count what comes off the assembly line, but downtime maybe 2 or 3 hours a day. But this particular impact should also be counted. So, if you've got a factory which is offline for an hour, for 2 hours, 3 hours, that also needs to be tracked. And therefore, monitoring sort of downtime, and also you can sort of perhaps take the opportunity. If you are reducing downtime, then you're also reducing unproductive energy consumption. You're also not having personnel, staff, managers standing around doing nothing. They're all optimized and being useful. And of course, reconfiguration. Some of these factories, like for example, car factories, if you want to produce another type of product, another type of vehicle, another type of model, you may have to reconfigure the factory, components have to move around, and that can take easily 6 months to 9 months. if you're rerouting power cables, that's inevitable. But if you're having to reroute Ethernet cables, then that's going to be painful. If you're using more modular, more wireless technology, you're going to reduce that downtime, so that's going to be beneficial. So, going to wrap up here. So my conclusions and recommendations. The cost of 5G equipment is coming down rapidly, and therefore this does give an opportunity for firms to evaluate the use of 5G. 5G will be very much integral to the next phase of enterprise connectivity. So yes, these enterprises could do it their own, but also they'll be using system integrators, often do it with their own private cellular networks, or they'll be using the mobile operators to help implement those solutions. CSPs and system integrators can help provide that expertise and value-added services and collaborate with the ecosystem to harness industrial Internet of Things growth. 5G can also therefore deliver improved return on investment, ROI, through real-time data delivery, productivity, and efficiency gains. And I mentioned a few times, also improve safety. And then, of course, in terms of enabling this, governments can have a role to play. That is essential. Government stimulation plans do not just simply be about saying issuing licenses, public licenses for spectrum. They can also provide, yes, subsidies, tax returns, tax reductions, but also they can stimulate coordination. So that coordination could be encouraging universities to work with local businesses, supporting localized R&D, helping to improve understanding of technology, getting that technology awareness and collaboration in place. And then lastly, spectrum is the essential agreement. A lot of spectrum is therefore covering the public spaces, the wide area coverage of the country, but also there's a role to play for private cellular spectrum. And this is an effective complement to public spectrum, and this needs to be seriously evaluated by governments. Lastly, I'll say thank you very much for listening to my presentation. And here is the final link for you to pay attention to. So that report I mentioned is here. If you take a snapshot of this right now or download this video, if you go to this website, you can download the report, the review of the 5G ecosystem adoption and industrial use cases in Asia report. Did this about a year or so ago. We did this on behalf of DCIT, the UK government, for science, innovation and technology. And it was a fascinating project and allowed us to look into a number of different countries. And there's tremendous opportunity. There's also the danger, and to be honest, I didn't put in my presentation, and that is COI, the cost of inaction. If you stand still, you're being left behind. On that, I'll say thank you.